Hi everyone, welcome to our video on the properties of functions and algebra review, where we will be evaluating functions. So first, let's just define a function. A function is a set of ordered pairs where no x coordinates are repeated. A rule will define y as a function of x. So often we'll see this as like y equals some x expression, but often instead of y, we'll use f of x instead equals some x expression. So it's just a variation on how we could write it. It's up to you how you prefer it, but often we will use the f of x form. Okay, so to evaluate functions, all we have to do is plug in a value for the x value that's in our equation. So to evaluate these two right here, so in this example, it says let f of x equal 5 minus 2x squared. To find f of negative 4, we can do 5 minus 2, and then the x is getting replaced by that negative 4. And we always use parentheses, so always use parentheses when we plug these in. And once we do that, then it becomes an order of operations problem. So we still have 5 minus 2, and then our order of operations, please excuse my dear Aunt Sally's loud radio. So the LR, the loud radio, means these go left to right. So it's multiplication or division, whichever one is more left. And then it's addition or subtraction, whichever one is, again, more left. So for instance, little side note, if it was 15 divided by 5 times 3, please excuse my dear Aunt Sally's loud radio is saying just go left to right on this. So do the division first. So 15 divided by 5 is 3. And then afterwards, we would times it by that second 3 to get 9. Okay, so that's what we mean, the left to right. So it's not multiplication and then division. It's just whichever one is first. Okay, so anyway, so just be careful of that. Well, anyway, so the reason I wrote this out is to help us finish this problem. So this means parentheses is what we would do first. And that really means if there's stuff to simplify inside of parentheses, do that. Well, inside my parentheses is negative 4. So that means it's already simplified, which means move on to the next letter, which is exponentials. Okay, so negative 4 squared is negative 4 times itself. So negative 4 times negative 4 is positive 16. Okay, and then we continue with the order of operations. Well, we have multiplication next. So 2 times 16 is 32. And then now we can finish it off with the addition or subtraction. Well, 5 minus 32 would be negative 27. Okay, so that's how we can break that down. All right, in number 2, we have a plus 5. Well, it's the same deal. It's just this is going to go in. Let me go ahead and do it in blue this time for the x that we see in our function. So it's already replaced this first one, and we're going to plug it into the second one. So 5 minus 2, the x I'm going to substitute out as a plus 5, and then afterwards it will still get squared. And so now that it's written like this, this could be the final answer depending on what they want us to do, but often they would want us to FOIL, so a little scratch work again, FOIL the a plus 5 getting squared. So a plus 5 getting squared is the same thing as a plus 5 times a plus 5. So it's squaring is the same thing times itself. And FOIL tells you to multiply the first terms. So a and a are first in this, so a squared. Then multiply the outer term, so a times 5 would be 5a. Then multiply the inside term, so 5 times a would be 5a. And then multiply the last term, so 5 times 5 is 25. And then from there, you'd always collect like terms when you can. 5a plus 5a would become 10a. So this all simplified as a squared plus 10a plus 25. Okay, so that's what all of that became. So this here, let me go ahead and put it all kind of in green parentheses. That was our scratch work, the foiling. And so now let's rewrite it. So this becomes 5 minus 2. And then the green parentheses we FOILed out. We said it's this answer. So a squared plus 10a plus 25, just like that. And then we would continue simplifying this by distributing the negative 2. So the negative 2 would go through and multiply these three terms. So it distributes and multiplies through all of those. Include the negative with it. So this becomes 5. Negative 2 times a squared would be negative 2a squared. And then negative 2 times 10a would be minus 20a. And then negative 2 times positive 25 would be minus 50. And then our final step in this would be to collect like terms. Well, we have two like terms, the constants. So 5 minus 50 would be negative 45. Okay, and we could put that at the end or we could put it at the beginning. So I'm going to put it at the beginning, so negative 45. And then these two terms are not like terms. They're just going to stick around though. So minus 2a squared is next, minus 20a is last. And you could rearrange the order if you prefer. It's up to you. So some students might prefer to see it as negative 2a minus 20a and then minus the 45 last. So that's the same thing. So those are the same answers, just written in different forms. Okay, so anyway, so there's a very, very quick review of evaluating some functions. The main thing is to just use those parentheses when you substitute. If you have parentheses with an addition in it, just like this a plus 5, remember that it requires FOILing, which is to multiply these terms out in this way. Okay, so let's do another where we evaluate a function. So on this problem, it's let g of w equal this expression here with these two expressions. So this is an example of a piecewise function. So this is piecewise because we would say there's two pieces. We have a top piece and we have a bottom piece. Now, notice they use w instead of x. That's fine. It's treated the same way. So we can still do this the same exact way as we did from above. All right. With this, though, we do have the two pieces. And when we want to start to evaluate, so notice on this one, they say do g of negative 10. Well, first thing we do is look at where that would fall in this set of inequalities. So if I plug negative 10 in for w, it would satisfy the first one, okay, because negative 10 is less than negative 3. So negative 10 is more negative than negative 3. It's further left on the number line. Okay, so that means we should use this first piece. So this is telling us use that top piece right there instead of the bottom. So it's always just one piece or the other. It's never both. All right, so now we know, hey, plug this into this first one that's listed. So we'll have 2, and then the w I'm changing into negative 10, and then I'm going to add 5. And then afterwards, when I now have my order of operations, well, 2 times negative 10 is negative 20. And then afterwards, we have plus 5. Negative 20 plus 5 is negative 15. Okay, so that's how that one breaks down. Now, in the second one here, find g of negative 3. All right, well, just like before, I want to look at these inequalities before I choose a piece. So if I were to try the first one, well, negative 3 is not less than negative 3. So negative 3 is equal to negative 3. So this is not true. So that means don't use the first piece. So we want to use the piece where our inequality is true. Okay, so this one doesn't work, but it does work for the bottom one. So let me just kind of cross that out. It does work if you plug this negative 3 into this w. It is true now. Negative 3 is greater than or equal to, so the equal portion is where it's true. Negative 3 does equal negative 3, so then it's telling us use that bottom piece right there. So now we're going to replace that w in the bottom piece with negative 3. So we'll have 3 times negative 3 getting squared. And then now it's still order of operations. Well, 3 is just going to be there first. Negative 3 squared is negative 3 times negative 3, so that's 9. And then now 3 times 9 is 27. Okay, so there we go. So there's our 2 values for that. All right, and then just to kind of go back real quick, when we first talked about the function, it said a function is a set of ordered pairs. So these just give us single ordered pairs. So it doesn't give us every ordered pair for the problem. But what this represents, like on this, and it's true for these as well, but let's just do the bottom, our second example. What this means is when we have our first coordinate is -10, our y coordinate would be -15. So we do get a point out of it. And similar with this one, if I have my first coordinate is -3, the second coordinate is 27 as a point. So these are useful if we had to start graphing it. Now, what is circled and what is boxed there are the answers to these 2 problems. These are just nice to know what they actually represent in a graph. Okay, and we can keep plugging in values into this function here to get more points to get a real clear picture of what the whole graph looks like. All right, anyway, so that's where the points come in. So these are pairs, ordered pairs. That's right. We also call them points. Okay, so but that's it. Let's take a break. So that's evaluating. Again, a very, very quick review of it. Let's take a pause, and then in our next video, we'll look at the domains of functions. So thank you for watching, and I'll see you next time.